Well, good morning and good afternoon to everybody. Thank you for joining us today. I'm pleased to welcome you to the Sierra Wall Gas Academy web event in conjunction with our partners Teledyne GMI. Our topic today is introducing the enhanced GS700 portable gas detector and ecosystem. And with that, I'd like to introduce our speakers. Patricia Kittelberger with Teledyne Gas Measurement Instruments. We know Patricia well. We've worked together for a long time. Without question, a subject matter expert. Any of you in gas detection in Canada, I'm sure you've crossed paths. Patricia is the Portable Gas Detection Sales Manager Americas for Teledyne GMI. Without question, GMI is a leader in portable gas detection for gas distribution market globally, and certainly in Canada and the US. Patricia has been providing solutions to utilities in Canada for more than 10 years and is responsible for the development and implementation of the company's strategic sales plan, sales coaching, and monitoring performance of our sales representatives and partners. Ken McDermott joining us from Scotland, Teledyne Gas Measurements. Ken is the Global Product Manager for GMI's portable gas detection products and responsible for product line performance, growth, roadmap, and commercial launch. Again, we've known Ken for a long time, and certainly if there's anything you need to know between Ken and Patricia, they've got the answers. Ken's experience extensive in gas detection processes for gas utilities globally. He joined GMI in '91 and spent 15 years in engineering department designing and developing many software and hardware products before moving into tech support, then product management. So with that, I would like to turn it over to you both. Again, thank you all for joining us. We are going to be taking questions in real time. So please use the chat feature in the Zoom system, and I'll read them on your behalf, and we'll get the answers on the go. Thank you.
Thank you, Mike. Good morning, everyone, and thank you for joining us. Thank you to Sierra Wall for organizing today's webinar. Ken and I are very happy to discuss the GS700 portable gas detector and ecosystem. Ken and I will be happy to answer all of your questions, completely informal, so please feel free to submit those to Sierra Wall webinar. GMI was founded in 1947. GMI is a world leader in the design and manufacture of high quality and innovative portable gas detectors, specifically designed for the natural gas industry. We are headquartered in Glasgow, Scotland, with representatives. Today we'll be covering topics around functionality, capability, application, the compliance, and new technology.
The GS700 is GMI's platform product. It's been designed fairly recently, and it's been designed with a lot of key functions, functionality, and obviously with the gas utility in mind. A lot of these functions are custom to the application, but this is not a general purpose instrument. It's an instrument that really recognizes the applications, and the software has been designed accordingly, and the interface for the user. So the features that are listed there, we have things which we'll talk about today. We have something called the pipeline gas discrimination, a useful feature for letting the user know the difference between the gas being detected. Is it natural gas, or is it a landfill gas, or methane only? We also have connectivity. We have GPS options, compliance features linked into data logging. The sensor technology is quite different from what we've used in the past. We have infrared and electrochemical sensors. And as you see there, the list of gases detected is extensive. And what we have on at the end is also hydrogen. And that's something we want to talk about today as well. Extensive runtime, as you'd expect, and a very good alarming feature where if gas is detected, then there's 360-degree alarms that fully alert the user when alarm is activated. And then finally, we have very configurable software. We fully understand that some of the utilities in Canada, they don't all operate the same. They have different processes, different terminology. So what we've done is we've made it completely configurable so that we can try and get this to look exactly what you need. And that's a very useful feature to try and to minimize training, for example, so that existing terminology is incorporated into the new instrument.
We've got a question, Ken, while we wait for Patricia to get resynced. With the GPS, can it store coordinates, and how many meters of accuracy is it, Ken?
Yeah, thanks, Mike. It's a good question. A lot of people ask, what is the accuracy? And I think what we need to understand is that there is no definitive answer for accuracy. It's actually a probability type answer. So it does depend on things like time of day, number of satellites visible. We do have the latest chipset employed in the instrument, and typically we can get down to 2 to 3 meters. We can get better, but it's a probability based answer, Mike. I think with the chipsets we're using, we do get around 2 to 3 meters, but that can vary. As I said, it can vary quite considerably.
Thanks, Ken. Patricia, are you back on board?
Yes, can you guys see my screen?
Yeah, we
Yes,
see the 300 with the operation pump operator maintenance tabs.
Awesome, thank you. This is the Gas 700 tool that we use for both our presentations, as well as it's a great user interface training tool for both user and operation and maintenance. So I'm going to show you some examples of how the 700 works. So if we click on the operation tab, we're just going to turn the instrument on here. Once that instrument powers up, it's going to go through a normal operation. Once we get to our main screen, show us our sensors that are being configured. Here's our main screen. And we're going to go ahead and we're going to change different modes. What we've got highlighted there is gas leak outdoor mode. We're going to switch that now over to our confined space. You'll see there on the top left-hand corner, it then tells you that you are currently operating in a confined space. One of the common things that you can also do is change ranges while you're in a mode of operation that allows you to make a specific sensor your primary sensor on your. We move to the pump operation of the unit. We have the ability of performing what's called a soundness test, but over here in North America, we call this a leak test, where we ask that you block the end of your accessories, the probe, and or the inlet of the instrument. This ensures that your sample is not being diluted and there are no leaks. The other thing we can create is what's called a sample fault, where we stall out the pump's operation, and the screen will illuminate red and the word sample fault will appear. You can then clear your fault, then go press the pump button on the left-hand side there, and your pump will turn back on. We look at some basic operator maintenance. We can look at replacing, if this was an alkaline unit, the alkaline batteries on it. Screws, and we pop the batteries out. Place in the new batteries, and if you have a rechargeable unit, you can then, there's a charger base. You'll get a low battery fault that gives you a warning that the batteries need to be replaced. Power your unit off and on its charging. We need to replace some probe filters. You can go ahead and do that. There are 2 filters found in the probe handle assembly. One is the hydrophobic filter and one is a cotton filter. Both are designed to reduce the amount of dirt, dust, and water vapors from. There is a filter inline the instrument that the end user now has access to. Typically, you're not going to do that with a penny. There's a tool and or a screwdriver that you can use. You'll replace that filter in line there and then tap back in. The next thing I'd like to show you is calibration. To power the unit back on here, we're going to insert the Gas 700 into your existing PD net. You will power the unit on, and an automatic calibration, the test and progress light, and whether it's a pass or a fail, those corresponding lights will.
We've got another question coming in. We'll Ken, maybe you can answer this. What is the time delay for sampling through the wand?
Thanks again, Mike.
Yeah, you bet.
Yeah, the transit time through the probe is probably in the region of about just less than 10 seconds. There's different lengths of probing adapters, but typically with the standard probe, it's certainly less than 10 seconds from the end of the probe tip right through to the instrument. Patricia, are you back on board?
I am. Can you guys see my screen entitled Leak Survey?
We can indeed.
Excellent. So what we're going to be getting into now is some of the applications that the Gas Surveyor 700 is designed to be used for. Leak survey is going to be the first one we talk about. Gas utility companies perform leak surveys as part of their normal operations and use technology to inspect their pipelines and identify any leaks. If a hazardous leak, typically known as a class 1 or a grade 1, is found, the action to eliminate the hazard is taken. If a non-hazardous leak is found, typically known as a class or a grade 2 or 3, then it's scheduled for repair and the leak is monitored to ensure that status does not change. Leaks identified on a utility system are investigated and graded in accordance with local regulations. Grading of a leak will vary by country, state, or province and local utility structure. Since the inception of leak survey, the technology used to detect below-grade leaks has advanced significantly. Certification is heavily weighted along with sensitivity, stability, and accuracy. Flame ionization, infrared, optical, laser, and imaging technologies are all utilized in various ways to decrease gas emissions, but today we'll be focusing primarily on infrared. With the Gas Surveyor 700, we offer two types of technologies to detect gas leaks from low-level ppm to volume gas. Infrared sensor can detect in increments of 25 ppm up to 10,000 ppm, auto-ranging in LEL, then volume gas at 1%. In order to achieve 1 ppm detection, we combined the stability and the accuracy of the infrared sensor with the sensitivity of the semiconductor sensor to provide 1 ppm increment in the low-level ppm range without sacrificing sample response and integrity. Combined with our dual-stage pump, which draws up to 1 liter per minute, pipeline gas testing, bar hole, bellows probe options, the Gas Surveyor 700 is your compliance leak survey instrument. The image you'll see on the right is a sample of one of our probes that we offer for leak survey. At the bottom part of the probe is located filters and our semiconductor. Image to the left is courtesy of our client and partner, Impro Energy. We're now going to be talking about.
Trish, if I could interrupt before you go forward here, we have another question. What would be the frequency for calibration of the unit?
Calibration frequency really is going to depend on a number of factors. One of the advantages of using infrared technology is that you can have a longer duration calibration as it's less susceptible to poisons and things that can inhibit that calibration performance of the actual sensor itself. So typically in North America, calibration intervals are set at either 3 or 6 months, but can recommend going no longer than 12 months within.
Good, thank you.
So we're going to move on to the bar holding feature of the 700, as this is common practice within the survey application. It goes hand in hand with performing our outdoor underground leak investigation. The main purpose of performing a bar hole, focusing on a approved grid pattern, will assist the operator in pinpointing ground leaks. Utilizing a grid pattern allows the operator to account for variables that can affect where the gas is. Looking for clues such as dead vegetation can assist in the investigation. The Gas Surveyor 700 has the capability of automatically capturing the bar hole data, displaying relevant gas readings such as the peak and operator best chance at locating gas coordinates, date and timestamp, which can be extracted and utilized for compliance reporting. In addition, the instrument will allow for consistency by configurable sample and purge time and bar hole number logging.
Patricia, Does it have to be
Above our screen,
tested?
yes.
Does it have to be pump tested daily?
Bump test is a requirement in Canada, also with the CSA standard. So this instrument is certified to CSA and is compliant with method 21. So there is a requirement to perform a bump test before each stage.
Good, thank you.
Above, you'll see screenshots of the instrument screen images the operator will see while using this mode of operation. Access this through the gas leak outdoor mode, and it will store data up to 99 bar holes. This data can then be extracted for compliance tracking or uploaded into our cloud system to be visualized on our mapping tool. So you will see here on the top left-hand corner, we are currently in gas leak outdoor mode. By pressing the downward arrow, you will then enter into the bar hole option. Select the bar hole option as the image on the top, and then you can start a new series. Once selecting starting a new series, you'll see the start button along with the plus or minus. Select the start button, the instrument will go into your first bar hole and it will be labeled as bar hole number 1. The image to the bottom far right hand corner, you will see that a bar hole has been completed. It will give you access to your along with your date and time. The plus and minus arrows located on the screen as well will allow the operator to move through various bar holes that he's conducted to help him or her assist in location. The next application we're going to be talking about is going to be related to purging. Purging in and out of service, assuming a closed system containing a flammable gas such as natural gas, requires the use of portable gas detection, which is capable of measuring both volume gas and oxygen. Measuring percent volume gas can be achieved with either thermal conductivity or infrared technology, with each one having their own set of advantages and disadvantages. However, we are going to focus primarily on infrared technology that is currently equipped in the 700. IR sensing does not require oxygen to operate properly and is immune to poisoning and contamination, which is often found during the welding process, therefore offering the operator safe and reliable reading. Limiting the concentration of oxygen, ensuring combustion is not possible, independent of the concentration of natural gas, is recommended by using chemical sensing technology. It is important to ensure the gas sample entering the instrument is at ambient pressure, as pressure below or above can affect the performance of the sensor and or cause damage to the system. If you are purging with pressure above ambient pressure, it is recommended that you place a one-way valve with a TP line of the sample tubing to reduce the pressure entering. The 700 series has a pressure sensor fitted on the pump, having a max flow rate of 0.5 to 0.7 liters, which will result in a sample flow fault in the event of a high pressure situation. The pump and the pressure sensor are fitted before the gas sensor, therefore protecting the integrity of the sensor performance and construction, offering the operator reliable and accurate gas reading. Welding smoke exhaust is identified as a contaminant. Gas detection technology, as there are small particles that can inhibit the sensor performance outside of the use of infrared technology. It is always best practice to replace filters often and ensure that you capture small particulate found in the welding exhaust to prevent damage to them. These are captured using specialized filters designed to capture small particles outside of your dust and dirt, covered by the standard filtering provided by GMI. The image above shows an example of readings being taken through a ball valve, which is a known practice in distribution systems in North America. The operator inserts the probe into the opening of the ball valve, which is under pressure. Operator's hand is cupped over to support the sample capture. Without a one-way valve in place, the 700 would sample fault and operate to supply instrument protection. Reducing the pressure to ambient is always recommended and is best practice. So the image in the middle you'll see here is a sample of the tubing going in line between the probe handle assembly and the instrument, with a one-way valve attached, relieving the excess pressure going. So I'm going to actually be moving to what we call our simulator that is going to demonstrate how the instrument itself works. So what I've done is let me know, Ken, when you can see my simulator. I'm not sure.
See it now. Oh, we lost it.
So
It's
how's
coming.
that?
There it is.
All right, so this is a simulator of the instrument actually working. We are currently operating our unit in gas leak outdoors. So I've equipped this unit, prepared it based on the presentation and the topics that we have discussed today. So what I'm going to show you here is we're going to apply some LEL gas. You'll see that the instrument will go into alarm, reading. One of the things you'll note here is that we have methane only selected and appearing on the screen. So that tells us our pipeline gas test feature, and it is detecting methane only.
Hey, Patricia and Ken, I've got a quick question here.
Yes,
This is about cumulative exposure, time-weighted average.
okay.
So the question is, ACGIH recommends a time-weighted average of 8 hours at 1,000 ppm for natural gas. Can any of the devices reliably detect an alert at that low level?
The instrument is designed to be flexible with the alarm set point on both flammable and toxic sensors equipped in the instrument. So if we're looking at, from a toxic point of view, which is going to be your oxygen, CO, and H2S, there are several alarm set points that you can configure there from a high, low, and also capture your time-weighted average. We do have the ability to put in alarms on the flammable range from a low level to a high level. However, I don't believe we can capture TWAs on the flammable range. Ken, can you speak to that?
No, the current time-weighted averaging is only on our toxic ranges just now. So that would be carbon monoxide and hydrogen sulfide. If there's a need to capture those on different ranges, then that's something we can take on board and certainly implement. We have the routines to do it, but it's certainly not something we've been asked for in the past. But it's a good point that I've recorded.
Yep. Purge, if that's a need, let us know. One other question came in. Should a one-way valve be used with the first responder in ball valve testing? I know the answer, but I'll let you guys go ahead.
Yeah, absolutely. So the first responder and the Gas Surveyor 500 series, as some of you may or may not know, is not equipped with the same pressure sensor that we have put into the Gas Surveyor 700. So if those particular instruments are exposed to higher than ambient pressure going into the instrument itself will take that pressure. However, the disadvantage to that is you will see some effect on your toxic sensors as they are sensitive to pressure variances. And what you could, over time, depending on the length of pressure, could actually do some damage to the combustion chamber. So it is recommended in high pressure situations that you do have a one-way valve in line with your tubing. And did you want to add anything to that?
No, I think the key message is, Patricia, we try and sample any brick type instrument, 500 based or 700. We try and, or we need to sample at ambient. So if there's a risk of a increased pressure, then we have to use this piece of kit to effectively filter off or drain off the excess pressure and gas.
Good. Thank you, guys.
Okay, so to go back to the simulator here, what we'll see, I left the screen sort of flashing like this. What you'll see is that I've applied air to the instrument and the reading display had changed to 0. However, you can still see our peak percentage LEL reading as well as our pipeline gas test response to that particular sample that went in there. That allows the operator to take a moment and those details to be able to do that. To be able to clear those details, you select the third button, you can clear those, and then we wanted to switch modes of operation, we're going to select button number 4. Go into our bar pull series as we talked about. We want to select a new bar pull. Yes, we do. Let's give that a go. We'll apply random mix of gas, air. You'll see our countdown timer on the bottom part of the screen. We have about 1 second left, and then here's our results. The peak was 110% gas, and our sustain was 0.5. I didn't do that. Flow quite nice, but there we go. So you can see how that works. We're going to purge the instrument out. By purging the instrument out, it allows us to move on to the next bar pull.
Patricia, are you using the simulator for training?
Currently, the simulator is used to set up a client's instrument, configure it to the client's needs. But yes, we have utilized this tool in training classroom platforms. However, we do not have a simulator specifically designed for training.
Thank you.
Back. So these are the 3 modes of operation that we have. We'll go into our leak survey mode here. You'll see that I've configured the leak survey mode to be slightly different than the other mode of operation. On the top right-hand side, you'll see our GPS is coordinated there. I've turned off all alarms, audible alarms in this functionality. I've made the ppm hydrocarbon sensor the primary sensor, and then the LEL on the bottom here. So if I applied some gas, that we can auto range that up to LEL. I've maxed out the ppm. We'll apply some air. You will also see that the pipeline gas test feature is also enabled. Clear out those results. Back. Screen.
Okay.
At this point in our presentation, we'll be transitioning from myself over to Ken. Both he will be carrying on with the remainder of our.
Thanks, Patricia.
So, Mike, can you see my screen now okay?
Yes, sir.
So, next brief topic is an overview of the pipeline gas test. A lot of people are very curious what it is, how it works. And very simply, it's a feature, an infrared-based feature that differentiates between natural gas, which contains lots of different hydrocarbons, or just methane, which obviously has the one. So you can imagine if you're doing a leak investigation and you take a sample, if it's methane only, then that might mean something quite different from an excavation to try and uncover a pipe where it might not be your gas. The pipeline gas test operates at around 30% LEL, and I'll come back to that shortly. What is worth pointing out is that this is not ethane identification. That this is an infrared-based technology. It's not ethane. It's not gas chromatography. And indeed, what we do is we have two sensors, two infrared sensors. One looking at methane or seeing methane, and one seeing all hydrocarbons. Now, this diagram here may explain it. So we have one sensor measuring all hydrocarbons, one measuring methane. This scenario here, on the left-hand side, the image is meant to indicate you're measuring landfill gas or methane. And the way to think about it from my perspective, if you think of both sensors acting like a balance, if you're measuring methane only, then both sensors will indicate roughly the same, because the sensor that can measure all hydrocarbons only measures methane because that's all that's there. And the other sensor that can only measure methane picks up the methane. So the instrument knows both sensors are reading the same. This is not pipeline gas. Now, conversely, if you're measuring natural gas, the sensor that can measure all hydrocarbons, that's now picking up not just the methane, but the ethane, the propane, the butane, what other hydrocarbons are there. And remember, the other sensor, which can only see methane, is exactly that. So now we have this imbalance where one sensor sees more hydrocarbons, gives a different signal, and that's very simply how we can determine is it natural gas or is it methane, and it's purely based on the hydrocarbons. Some things worth noting is that during lockdown last year, we've been looking at improving the pipeline gas test feature. We recognise 30% LEL is a fairly high threshold. So we have now a new sensor with new infrared parameters and filters, and we now have that down at 10% LEL, 0.5% volume. Our targeted release is Q2 this year. We have some certification to complete, and we have independent testing as well, which is nearing completion. The other thing which might be of interest is that the pipeline gas test is a nice feature. One of the utilities in North America asked us if we could incorporate that into the calibration. So they have a pipeline gas test feature, and they want the calibration to indicate that feature was tested and was working. And as perhaps you can see on the screen there, we've done just that. We can now connect natural gas or line gas, if you like, to the GDU, and we can have that as part of the calibration. So that now validates the performance of the PGT feature.
And Ken, just to note, the pipeline gas test feature, if ordered with your instrument, is a configurable option. Every sample that the instrument takes, in fact, if configured that way, will process whether or not it is a pipeline gas or naturally occurring, correct?
That's correct. So it's quite a configurable option. You can configure it to measure everything and report everything to the user. So you can report to the user, yes, it's natural gas, or yes, it's methane. Or you can configure it just to report the exception, which is typically methane only. Every measurement that's performed is analysed, and also, Mike, as well, is data logged. So if there is a decision that's recorded that's not pipeline gas, it's recorded in data logging as well.
Thanks, Ken.
So the next topic is field data, is business data. What I'll do is I'll briefly escape from the presentation, and what I would like to do is just briefly show you something else. So what we have been developing is a cloud-based solution. And if I sign into the cloud just now, okay, so that's better now. So we're logging into the cloud system. And what we're doing at GMI is we have our instrument management system, which captures instrument calibration and fleet status. And what we're looking to do is transition not just that, but other functions onto the cloud. So what we have is we have bump data, calibration data, and session data all going to the cloud. What I can do very quickly here is select some results. You can see I can enter dates of interest. So if I go back to October, for example, select the start date of the search, select the end date of the search, click apply. What the system's now doing is looking for all the calibration results within that period. And you can see there's quite a few records appearing. Very, very briefly, what we have here is a summary: instrument serial number, instrument type, when the time and date of the test, is it a calibration or a bump test, and very crucially, is it a pass or fail? This is the overall pass or fail. If I click on one of them to get more information, then you can see what happens on the right-hand side. I'm drilling down to get more information. There are all the air test results. There are all your gas test results. If I look at the one that's failed, then I can see that the carbon monoxide, we applied 100 ppm, the sensor read 0. After calibration, it didn't fix it, overall failure. So this is your calibration data. This is your bump data. It's now captured on the cloud. Some of you may be familiar with our IMS FlexiCal Plus doing it locally. This is extending the option. We do find that increasingly with IT departments, it's increasingly difficult to get access to networks. So that this is an option of totally bypassing that. It goes straight from the equipment, the calibration equipment, straight to the cloud. So that the bump and cal, there's nothing that's probably what we've seen before. If I now move to the GMI session data, this is probably more of interest. And again, I can put in a search for data. And this time, if I go back to September, I can enter the dates of interest. And again, click apply. And what the system is doing is it's looking for all the session data that was extracted from the instrument and pushed to the cloud. Probably worth asking, what do we term by a session? A session is quite simply when the user switches the instrument on till it's switched off, everything that's captured in that instrument is a session. So that a session is everything from on to off. What we see here is a summary of, there must be about 10 sessions captured. It gives you a summary of the session, again, the time and date of the session. It also tells you which modes the user had selected in that session, so that the black boxes indicate, it may not be clear, but it's monitor, bar hole, purge, survey, confined space. If the box is black, the user has gone into that mode. Last column here is any alarms, and if there are, the line's red. What I'll do first is I'll look at one set of data. So if any of those sessions are of interest, you click on them. So what I have done is I've clicked on the bottom session, which was the 17th of September, and it tells me that there was two, for the complete session, the user went into monitor mode and went into survey mode. We've captured everything that the user did. And the monitor mode, as you can see, has this instrument's GPS. So we capture all the data, all the gas readings, and there is all the data captured associated with those readings.
So Ken, just a couple of quick questions. How is the data passed from the unit to the cloud? And is there Wi-Fi?
Yes, I'll come to that very shortly. I have a couple of slides to show that. But essentially, it's the calibration equipment that pushes it to the cloud.
So that's the GDU.
Yes. Sorry, I should have explained that to begin with. So that is showing you everything that happens within the session. If I select one of the ones in red, let me go to the survey first of all. So the survey this time captures not only the date or the table of results, we also have a graph. And again, we also have all the logged readings. Now this looks very busy. You can perhaps see that all the log data is also in the table. Someone here set this to 5 seconds. I suspect this was in a car or a truck, but you get the idea of where the person has been. If I select one of the other ones in red, that this is a different session. When the data is recovered, you can see that this person went into about 6 different modes in the instrument: monitor, confined space, purge. And you can see that in confined space, there was something, an alarm was set. So if I click on confined space, you can see over here that there's all the log data. And indeed, one of the points shows you the alarm was exceeded. There's also a graph produced of all the data. You can hover over the points and it tells you specifically what it is. But I think you can tell from this response here, I think this was myself or someone simply opening a cylinder of gas and getting the infant to respond. But you can see typically a table of all results, a graph. We do also have the GPS in this mode, but often or typically, if you're indoors, the GPS will not get a signal. That's not guaranteed. So that's the session data. What I can also do is, you can see here that there's 4 or 5 other modes. One of the summaries is telling me pipeline gas. So if I click on that, then again, you can see what the table's telling us is that once we exceeded the pipeline gas test threshold, in this case, the reading was your gas. It was natural gas, which is reassuring. Again, you can zoom in and see where in the map you are. If you click a point here, it highlights on the map where the point is. Like the calibration, I can create a report down at the bottom corner, PDF report. If I click on that, it takes you to a slightly different function, but it can create a PDF report of everything that you see on the screen. So what you see now, that's the PDF report generated. I can email that to anyone who wants to see it. So what I'll do, Mike, is I'll jump back out and back into the presentation. So the question was, Mike, how does that data get to the cloud? So
That's right.
This slide shows you the way that happens. There's your instrument. The instrument is inserted into the GDU. The GDU has a router attached to it. So the GDU extracts the bump, the calibration, and the session data, and simply pushes it up to the cloud. What we do have, just as an aside, we can still push the data into a network. So if you have a network and we can access that, we can push it to the network, and that would save the additional cost of a SIM card in the router.
And Ken, with the Bluetooth feature on board, is there roadmap for other data transfer possibly in the future?
There is the Bluetooth opens up possibilities for us in terms of exactly that. If the problem is getting the data to the cloud, and obviously Bluetooth would not do it on its own.
Right.
So there's the possibility of a 4G or a 3G hub, small device, and that is Bluetooth enabled, and the instrument can talk to the hub and then push it onto the cloud that way, Mike.
Or to Field Tech laptop and up as well, right?
Yeah, exactly.
Okay, thank you.
Okay, so the next topic, very quickly to run through, is hydrogen. I'm sure most people are well aware of the global need to do something to eliminate global warming, and hydrogen has been identified as the silver bullet to reduce the carbon footprint. If we can remove, certainly in the UK, heating in the UK accounts for over 30% of our carbon emissions. And if we can do something with our heating, with our natural gas, then a huge contribution. We have been working extensively with 3 gas utilities in the UK. This is almost 2 years now. I've put the details on there so you can look at them. But one's called High Deploy, which is a blended gas solution up to 20% hydrogen, and the other is H100, which is 100% hydrogen in pipes. The 20% hydrogen has been selected for various reasons, not least in the UK, that 20% can be added with minimum impact on downstream equipment, domestic equipment, the minimal that has to be changed. But there's also, next slide, I think, yeah. But there's also implications on the instrument. The High Deploy project selected the GS700, and some of you might think, well, how is that possible? Because the GS700 has infrared sensors, and infrared doesn't work at all with hydrogen. What we found with this project was that the response of the instrument was so good with the blend that, quite simply, if you had 20% hydrogen in the pipe, then this would read 80%. The balance would be red, and that was accurate enough for this project to progress. not ideal. And as you'll see later, things have moved on since high deploy, which is that was almost 2 years ago that started. What we found we had to do, we had to work out what the equivalent LEL volume gas conversion factor was, and consultants within the project evaluated that and determined that with a maximum of 20% hydrogen in the blend, we had to modify the instrument so that 3.7% volume gas, that the blend was equivalent to 100% LEL. And interesting to note as well, even with 20% hydrogen added, the LEL changed slightly compared to natural gas. It was approximately 95% of natural gas. So yes, there's a change, and yes, there's lots of issues, but in terms of the LEL, slight change. The other project that we've been working extensively with is H100. SGN, Scottish and English Utility, are putting 100% hydrogen into pipes. And you can see from the map there, the location has been picked in Scotland. That's not far from GMI's facility, 50 miles or so, or 80 kilometres, 90 kilometres. And what was asked of GMI was to come up with an instrument that could do both natural gas, 0 to 100%, and 0 to 100% hydrogen. And that's what we produced. We produced that over last year in partnership with SGN. The instrument has now been certified, and trials are ongoing. They started last year, tail end of last year, and ongoing this year. So again, we're using the 700, but this time we've added other sensors. So we still have the infrared sensor for the natural gas, but GMI, we design and manufacture other sensors ourselves, and we have looked at our catalytic and thermal conductivity sensors, and our engineers have modified the operation, so we're now using those to measure the hydrogen. And the table there shows you how it's possible. So we now have effectively 3 sensors that can measure all 3 or measure all gases. But this instrument, crucially, was designed to measure either natural gas or hydrogen. This project wasn't looking at blends, but this instrument will measure quite happily either gas coming from 100% natural gas or 100% hydrogen. The testing, we have a test facility in the UK, in the north of England, and the pictures show you what happened. The image in the top right, that is the hydrogen, effectively the hydrogen distribution pipeline, and it's feeding into these houses here, and our instrument here has been used for all aspects of commissioning, purging, leak investigation, and you can see on the screen that it's telling you that there's a hydrogen reading. There's been a huge amount of interest in this instrument, and very, very quickly we've been working with these other manufacturers of boilers. Worcester Bosch, Baxi, European based, but we're now working with those and supplying them equipment. And finally, Steer Energy is a UK funded organisation to investigate developments, and they're funded by the UK to make sure this instrument is performing properly in all aspects of leak investigation. Just to pull it to a conclusion, the trials are ongoing. We are working with more and more utilities. One thing we don't have yet is a GS700 working with blends, and maybe I'm happy to work with utilities. We're working with 2 in the UK just now, but I'm happy to work with utilities who have perhaps a more proactive blended hydrogen project and are looking for instrumentation and wanted to move that forward. I know there's lots globally, but if that's of interest to you, please feed it back to Mike or to CRWall, and we're happy to talk to utilities.
Ken, we've got a quick question with regard to hydrogen. Is it difficult to add the hydrogen sensors to the GS700 retroactively?
Well, that's a good question. we've taken on a couple of contracts recently, and have supplied instruments in America, in the USA, and in the UK. And their requirement was that they would purchase them only if we could add hydrogen at a future date. So absolutely, Mike, this was absolutely designed to be able to fit the sensor retrospectively. We'll obviously have to open the instrument, fit the sensor, reprogram the instrument, but that's all that has to happen. And we've done that already.
Excellent. Thank you.
Okay. So finally, I know we're fast approaching time out. Just something perhaps of interest. If anyone recognises that phrase, let me know. But one thing that happened last year was that CR Wall was approached by a utility who had a particular ask, and it came back to GMI, and you can see there what the ask was. They had a safety ask. They had an issue that they thought could be improved, and they wanted to eliminate people working at height using cherry pickers, and they wanted to sample gas somehow on the ground. And you can see what the requirements were. They're looking for a 10-meter probe, which is fairly extensive. And I have to be honest, when this came back to GMI and we looked at it, our engineers looked at it and we thought that this is a tall ask. But we persevered with a lot of good input from Energear and from CR Wall, and we progressed that probe into an active project. And what we produced was exactly what was asked of. We produced a probe that could extend to 10 meters. We also had the probe so that it could be transportable in a truck. We also created different end pieces. So not only could you sample gas at height, but you could also, this was meant to be a spanner and turn a valve. And there you see here, you see an operator with the probe fully extended, taking a sample at height. And if you can see that, you can see the probe sampling the gas. And that has saved them running their cherry pickers and working from height. What I have very quickly, Mike, is just let me know if you can see this okay. We have a very, very short video of this being used in practice. So you can see the probe fully extended. You can see the probe adapter at the top, which has filters inside, drawing the sample from the burner at the top. Obviously the transit time will be longer to get the sample down there, but you can now see that the reading on the instrument, 110, 115 ppm, and they were very, very happy with the progress of that. So a very interesting project. And what I would say is GMI has a history of working with utilities. If things come to mind, asks, please ask.
That's great, guys. A couple of minutes left. Any questions out there? I just wanted to review a couple of takeaways, and this is what I kind of noted, Ken and Patricia, and thank you very much, by the way. So for me, in addition to the CGI combustible gas indicator, toxic gas detection, confined space, and bar hole, the new GS700 also addresses the pipeline gas detection capability to be able to detect pipeline gas versus naturally occurring gas, and also the new leak survey mode. And what that really translates to is really reducing or eliminating the requirement to have these extra instruments in your fleet, like an ethane identifier or an IR device specifically for those applications. So it's really kind of I'll use the term, the Swiss Army knife of portable gas detection, if you will. And the other thing I heard was with GPS, the new cloud. I mean, I'm a real fan of this. I think this is a bit of a game changer, and we certainly are excited by that. And I hope everybody can see the capabilities, both in your ability to just manage your fleet from a bump and count perspective, the ability to report and to share that reporting across your organization. In addition to, of course, to all of the capabilities to support your traceability and compliance. And last but not least, hydrogen. Anybody out there that is interested in hydrogen, would like to, your company's got some projects, wants to do some testing, please reach out, talk to myself or your other Sierra Wall representatives. So a couple other questions here. Will the PowerPoint be shared with the webinar participants?
Absolutely, mate. Yes.
Yes, we'll be following up then with a link for everybody to a recording and the slide presentation as well. And one last one, will you be, there you go. And the recorded session, so that was answered as well. So again, guys, Patricia, Ken, thank you very, very much. This was outstanding. To all our guests, thanks for being here. We hope this was valuable for you. And again, if there's anything any of us can do for you, please reach out, let us know. We are here to help you and support your business. So with that, thank you, everybody, and take care.
Thank you.